Раз, раз, раз.
Нет, есть.
Коллеги, всем привет. Спасибо, что остались. Будет очень тяжело.
Thank you for staying. So you'll enjoy it. So the developers, raise your hands, please. Almost all of you. Good, thank you. Cool. Admins, no admins, managers, hands. Yeah, few managers, but cool managers. And analysts. Thank you. I'll try. So then we'll go technical. There'll be a lot of math, but I'll try. I want to say a lot, but no time. So 6 hours. I need to talk about it. So then I'll try to be very brief. I'll come out with some metaphors. So like an elephant with 10 horns. So if I go into higher math, so we'll get stuck. So just open your mind to me, and then we'll start enjoying it. Okay, let's go get deeper into the subject. What is recommendation services? Recommendation services. What is it? Why do we need them? So how can we make money on them? And so the goal of my presentation is to teach you how to make money, to give you some value-added service. So let's look outside, what it looks like from outside, and so then lots of data, and how this our cloud service is organized. So 1C Bittrex big data. I don't want to sell. I will just tell you what it looks like, and then you will select what you want to buy, and then where do we move in future? So in 1 year's time, 2 years time, where the world is going to, and what kind of code you need to write, and how to do it. Okay. So then personal recommendations. Why do we need them? First, and so the Windows are watching us closely, and so our Android tablets are watching us closely. So they collect all the information. So they're watching us. Big Brother is watching us. How? Why it's needed? Because they calculated in the West. Microsoft and other big companies, they calculated many years ago, and Yandex calculated that an application should be relevant, because when you meet someone as if you had been waiting for him, that's much better. It's not a sales pitch. It's much better. So because we fight for relevancy, because who provides the most relevant proposal, so he sells much better than anyone else. So then to increase the level of relevancy, I say you immediately increase your sales and you become rich. And then so if you start spamming your client, so they don't understand that what is big data relevancy. So they do the carpet bombing. So they say buy scooter just for everyone. So some will buy it, and then it's I was thinking about the scooter, so and they offered it to me, but it's just only coincidence, that this relevancy coincided. It was a contingent relevancy, and that is why you cannot just send to everyone, because you lose more than you stand to gain. So that is why the pinpoint bombing is much more efficient than the carpet bombing. There are the trends: relevance, logic, timeliness, and don't overdo it. Don't overdo it. So they're trying to entice us. So with the help of math of the big data, let's talk how they do it. So how they entice us, how they attract us. So how do we rise to the bait? Let's see. So for example, everyone knows iPhone is so important. They just drove into your heads. It's like Pepsi Cola. And so they told us that iPhone is important. So how can you sell if you do not convince everyone that iPhone is so important in your lives? And this is the gregarious feeling. So this is the moving with the crowd. And if you, so for example, so they buy chips or nuts. So for example, or they buy first an axe, and then they buy a harmonica, because if you kill someone, then you play harmonica. So then one is connected to another, so then what else? The cross sale, upsale. So then they're trying just to refer you to another. So people just go and watch these goods. And so now they're trying just to identify the connection between the products, and what might be needed. So we need just to remember. So the exact product and its analog. Then another rules. So for example, so again, this herd feeling when you move with the herd. So then I took it from my book, a small data set, mining of massive data sets. Very good course. So read it once. Wonderful. There is wonderful chart. Distribution of sold goods depending on their amount. So some goods sell well, and some slow bestsellers sell well, and not bestsellers don't sell well. So because it works only for the bestsellers. So the long tail does work for the long tail. So that's why. But we need just to teach the long tail to sell, but it won't sell using this method. That's why we need to find other way. And so the Amazon.com. So Amazon, so they remove the prices from the front page actually. So because the price depending on our wishes actually. Can you imagine that? It's flexible. Amazon, Amazon at the top, they calculated that they need to offer things similar to what you've seen. So that's personal recommendation. There should be like, then you sell something. If you start paying, so then they offer you some goods for free. So this personal or non-personal, you don't know. Maybe it's personal, maybe not. Then what other shoppers are looking at now? What are they seeking for? So bestsellers. So why this a camera? Why? Because you probably just went through digital cameras. So they saw it and they start offering you digital cameras as bestsellers. So they are enticing you. They are attracting you. So how to entice? Some personal hooks. Personal hooks. And then this is a technical issue. Some personal hooks. So they need to hook you up. You need to get hooked up. And how this person for you, customer centric. And the people that look like you, so they find people that look like you mathematically, and then they understand what they're looking for, and then so your colleagues, your friends, so your social group, your income level, so they do the same, because they know that they profile you because you're in this cluster. You can get offer a good discount that they can say no to. So, for example, because they know they want to give you a discount because you are ready to pay, or you can even just raise prices or lower prices. That's big data too, and that's all good content. For example, just not just to offer to buy, but just to good content, and then catch you, and then uh, relevant search. For example, you bought a Toyota, and you're looking for wheels, and the system will give you the results, give you the wheels, and there's so different types of wheels. But then certainly there will be certainly Toyota will.
So
Даем релевантный контент.
it's a bit of a game. So, the click coefficient. Oh, yes. Uh-huh. Well, now let me give you some more data. Collaborative filtration. I'll tell you later about it. It's more complex. People don't understand it. It's a problem. It's a real problem. Even developers don't understand what it means. So let us start with content-based recommendations. What is it? We make a text portrait of a person, the words and the tags. It's a cloud of words. Words and how many times they were used. Then the text mathematically can be presented as a vector, is multi-dimensional space. One means that this word was used somewhere. It's a point in a multi-dimensional space. So we can build your profile out of those dots, and we can build a profile of a product in the same way. We can calculate cosine of these two profiles. It's a very simple algorithm. I believe everyone understands it. The problem is that the space is very large, too multi-dimensional. It takes a lot of time. Calculations take a lot of time and effort. For example, nice, good, beautiful are synonyms, and we shall get 3 dots instead of 1. So, of course, we can build a model of language, but I can offer you a a library, a neural network which uses big data. It's not deep learning. Uh, it glues all the synonyms together. Then the vector space model. In big data, it doesn't work very well. Word2vec is the best one, I think. Word2vec looks like this. Two-layer neural network. You pass all your texts through that network, and uh, this approach makes your space smaller. It compresses the space and makes calculations easier. We have some other similar systems, but they are more complex. If in the text descriptions you have many errors, you can apply additionally vectorization of not of the words, but bags of words. Collaborative filtration, that's it. Not all the people understand how it works. We have a matrix, a user, you know what it means, and we have to find other users similar to you, so which have more similarities with you. So you can see how many, so it's elementary. We can see those who are similar to you and see what they bought, which you didn't buy yet. So if we all saw Star Wars, but all of them saw Interstellar and I didn't see Interstellar, then we have to offer Interstellar, and you will see Interstellar, because this is the vector. However, it doesn't work in production. Mathematically, it's nice, you can sell it, but in practice, it doesn't work in the product space. You have to index this matrix. It has a lot of dimensions. It takes a lot of time and effort. Amazon uses a simpler approach. We have pairs of products which are bought together. The more linkage is between two columns, the more similar they are. If you have beer, and beer has a lot of similar linkage with crisps, I will buy it. If I have a X and then harmonica is linked, then harmonica will be offered to you. Algorithmically, it's simpler, and you have a bonus. You can make a search. Look for columns similar to this one. Accessories, analogs. This is the algorithm, user to user, KNN. Takes a lot of time and effort. Item to item is simpler, works much faster. What did we do? We use Mahout taste matrix in memory with hash tables, hash construction. No, wait, with line probing. Line probing, you know what it means. You read NUT. It works fast. We work in Spark. Look at Spark MLlib. It's an algorithm, but we had too much data. But it can compress your space very well. What else did we do to improve collaborative filtration? We compressed the catalog. Instead of 20 million products, we have 1 million now. We glued duplicates together, and actually the customers felt the difference. We just merged the synonyms, and everything started working well. For example, we have clusters, and in the cluster there are groups of products, and we must develop a personal recommendation. We choose the products which are most popular in the site, and we rank them. more popular go higher, less popular go higher. We use mean-wise independent permutation locality sensitive hashing scheme, min hash. Big sector is compressed with a small into a small sector. A vector may be a user or a product. We can statistically compress it with the help of hash functions. And if we had 100 dimensions, 100,000 dimensions, of course we can reduce the number of dimensions to 100 dimensions only. So it helps you compare the vectors much faster. We also use hash because this method is very well compatible to LSH. If you need a similar vector, so you cannot compare to all the vectors. As a result, we use LSH. So ask me questions later after the presentation. We had a lot of errors in product names. We created a shingle. You know what a shingle is. We shift the window, and if there are some errors in the words, still the text will be similar. Shindling works. It actually works. Put it down. So vectorization is ready. We have compressed vectors, and now we must work with LSH. What is LSH? It's not clustering. It's locality sensitive hashing. We define hash functions and focus the catalog on them. Products which are similar, they collide into one band or structure. So in one process, you get a collision of all similar processes. So you don't need several iterations. In AltaVista, it was used to find duplicate pages, and there are no analogs. It's a good positive method, otherwise it will take you too long. Banding. What for? To see coinciding vectors if they coincide in at least one band. So it works. As a result, in 2 to 3 hours we have a clustered catalog compressed by an order of magnitude. Everyone likes it. Users, business. How to measure quality of personal recommendations? We use classical methods, recall and precision. You know how it works. We take the old model, take the profile, user profile, predict the product, and see in a month's time what he actually purchased. 20%, 30%, 40, 10%. A person buys something, and if he buys what we recommended, then it means we are right. How our cloud service is built. This is implementation without mathematics. We take data into Nginx. We take it, store it, and provide people with personal recommendation. We take Nginx plus Lua. Why Nginx? Because it's our product, our local product. It's a nice product, very well defined, very well developed in one process. It processes a lot of sockets. We get to Amazon. We use Amazon Kinesis for buffering and queuing. Why Lua? Because Nginx is not doesn't have good documentation. It takes a lot of time. That is why we take Lua as well, but we authorize ourselves in Amazon. We put everything to Amazon, bufferize them. Why Worker? Why PHP? Well, because we were lazy. We can use Java if you like. And then we save it in Amazon DB. Then from Amazon DynamoDB, we move to Amazon S3. It's an object storage. Then we process it at Apache Spark cluster, calculate the models, download it as servlets to Mahout library, and then we calculate online recommendations. 50 to 70 milliseconds, sometimes more, but it works rather fast. We have tens of thousands of shops, and we need 2-3 servers to give all the recommendations. So if you have a lot of sales spots, a lot of shops, just one matrix is enough for you. Thousands of queries per second to the service, 20,000 internet shops, conversion from 50 to 80%. Some sales in some shops, sales are based. All sales are based on recommendations. Apart from personal recommendations, people use very often that together with this product, they usually buy such and such products. So personal recommendations are not always used. People liked to see what other people bought. With this product, we use a small Spark cluster, one recommendation server. It looks like big data. We have more than 300 million unique users. API, personal recommendation. You can see we save cookies, we merge cookies. We use JSONs, list of products for such cookie, personal recommendations, and similar products, collaboratively similar, which are looked for together with this or which are bought together with this. It's like the beer, and crisps. Different type of products, but often sold together or searched together. Through this matrix, we build top products, top searches, top sales in domain. I can tell you on a one-to-one basis how we do it. We look for similar vectors and put them on top. Where are we going next? Actually, we have to look at the gender. Please don't recommend huge boots to a woman, although sometimes there are some very tall women. Then age, price category. So you have to analyze your cluster. Then products. So some products are like bread or milk. So they are renewable. They are sold again and again and again. Then price, internal cycles, readiness to buy. We use Markov models here, classical ones. That's all questions, please. I'm ready to answer. Thank you. The question is, you have one server for recommendations. If it fails, what happens? So it never happened. And then if it happens, then you can have 2 servers, if you like. So clustering and fault tolerance. We have several data centers working on a 24/7 basis. Clusters, resilience, reliability. So it is not a physical service, but it's a cloud service. Oh, yes, it is a cloud in Amazon. Of course, if it fails, no, you can have 2 if you like. Until one, it never failed. Thank you. Are there any more questions, please? Don't be shy. It's a huge topic. You talked about collaborative filtration. What about, well, if a person comes in, collaborative doesn't work because the matrix is not filled. In that case, content-based approach is needed. If he hit only once, for example, harmonica, then of course you can offer an X to him. Content-based approach learns about a person's behavior. If he clicks twice, we know already his profile. We know where he is heading to. If it's a cold start, if there is no previous history, then we showed him top products, something which are not personal, and they work well. As soon as we collect data about the user, of course, we use it. Sorry? What about cookies in browsers? It works. Well, we have 20,000 shops and we collect data for all of them. If a person visited at least one of them, we know his interests. We don't use content base yet. Until now, we have collaborative only. We know a lot. Even a person goes to a shop once, it goes to our system at once. Thank you for your presentation. The question is like this. You build a model, you provide recommendation. How do you know that the model is no longer relative and it has to be changed? Yes, so we have been thinking about it, and the result is that well, we use 1 month's old model, and we download all the changes and datas every day. User interests are changing faster than links between products. Links between products are stable, unless prices stay the same. It's a problem, actually. Streaming, for instance, how to keep a model actual and current and fresh. We use that approach. We're thinking about streaming algorithms, continuous, unbreakable. We have few algorithms. We, we need a lot of work. Can we take into account external factors? For example, not to offer winter hats in summer. It's multi-modality. The more models you have, weather, age, gender, age. Well, you have to have several models plus content base plus collaborative. Then, by merging all the models with different weight, you will predict much better. The more factors, the better. And you have it. No, not yet. But we want to do that. We're talking about it. And also, I would like to add, look, sometimes that could be not enough. Analysis is needed. You cluster your users into clouds. You don't know, you cannot predict that, but you can see that this is a cloud of pregnant women, this is a cloud of rich persons. This is done automatically, and then you start adding the cluster. Well, mathematically, the behavior of a girl was belonging to a pregnant cluster. The family protested, but actually she became, she was pregnant. She didn't know about that. But her behavior pointed out to that kind. So you build a model of a behavior. The model is stored. Access, for example, that person buys access, but then a new X model appears. Then we have to find out who of existing X buyers could be ready to buy a new type of X. And then you send a new proposal only to that narrow sub-array of users. But this is an advanced approach. It's not difficult. We use different mathematical models. I believe this is the main trend. You processed a lot of data. Did you get any unexpected results? Good question, thank you. Robots go here and there, bots, they pollute cyberspace. End users more often they think use similar products function. Then often people come to a shop, make 1 or 2 hits and go away and never come back. We have very, very few loyal buyers. That's a problem. And we don't know how to make them come again. In mobile phones, they have a notion of churn. But in internet shops, that churn is everyday, a factor of everyday life. Nobody knows what to do with it. So a pregnant woman within 9 months will give birth to a child. Are you going? Are you monitoring something that in 9 months we have to offer something? Well, it's Markov model. Uh, the trend is called next best offer for that particular person, where we must take into account future events. If he buys this on a regular basis, 2 or 3 times, you can remind him of that, because there is a certain internal cycle for that man, that he buys something, consumes it within, for example, a month and a half, and then buys it again. If he forgets, you can offer. Uh, so it's just a statistical method. You have to process statistic. You can find out how many children has that person statistically, because such and such products are usually purchased by a person who has babies of this age. Then you have tag the products that the products are intended for babies of this age. So multimodality, the more factors you take into account, the better. How do we have to measure all that? How to measure quality? You'll never prove that it works. We understand that it works. The West understand that it works empirically. Of course, you can test, A/B test, enter products without personalization, then with personalization, and you will see the difference. There is no other way to prove that it works. And secondly, I told you about a lot of mathematics. And sometimes the market seems to love mathematics. So that was a problem. But now, well, mathematics are in hype. Well, but if a person doesn't know anything about mathematics, try to speak in simple terms so that he would understand. If you have no more questions, good luck. Goodbye.